Hi students, here we are going to discuss about the primitives for the distributed communication. We already seen the introduction about the distributed computing and what are all the distributed systems and everything. In distributed systems, we know that each and every system is connected by a network. Each and every system has its own memory and the processor. So each and every processor and the memory will be connected to the network and will be communicating. Okay, next, the primitives for distributed communication means if each and every system wanted to communicate with the another distributed systems, means need to send some messages. It will be working based on the MPA or RPC. MPA stands for the message processing interface. Another one, RPC, stands for the remote procedural call. The two important messages are the send and receive. Okay, if you are sending a message by to the other distributed network, then it will be sent by the will given the reply to the receive messages. Okay, so if we having the primitives for the distributed communications, we have four types: blocking and non-blocking, synchronous and asynchronous primitives. Okay, first we are going to see about the send and receive messages. Send means it is a function. It starts with the send function. It has at least two parameters: the destination of the what we have to send the message and the buffer used in the user space. Next one is receive function. It is also has the two parameters: the source, which one we will be getting the messages, the source of the message, so the source of the system, and the messages what we have to receive, that will be stored in the buffer. Buffer means it's an external memory used to store here. Okay, there are two ways of sending the data when the send primitive is invoked: the buffered option, and another one is unbuffered option. The buffered option means that the standard option copies the data from the user buffer to the kernel buffer. It will be it won't be directly copied to the networks. First it copy the data from the user, then it will be moving to the kernel buffer. Unbuffered option means it will be directly copied to the user buffer on the network. Okay, so this is the user buffer on the network, that is called the unbuffered option. Next one is the synchronous primitive. A send or receive primitive in synchronous in both send and receive handshake with each other. Synchronous means both will be working and both will be taking care of the send and receive messages. Okay, like if you are sending a messages, it will be automatically give the reply to the based on the receive messages. If you see that example, in the process A wanted to communicate or send the messages to the process B, it will be sending, waits for the responses from the process B, because if you are sending a messages in this particular time, it will be receiving all the messages. After finally that will be giving the responses to the B. So the process B will tells to the A, so I received the messages, and then you can start your work. Then after receiving this particular thing only, the process will be continued in the working conditions in the process A. Okay, so this will be the synchronous primitive. So if you are getting the responses from the process B, we have to wait for it. Okay, so in this asynchronous communication, it is just opposite of the synchronous communication. Here we have the example for this. Here also the process A calls for the process B. Again the messages will be copied in this process B. Now it will be getting working on the next process. Okay, it's not waiting for the response to get it from the B. It will be starting working on the another process. So this will be, we can call it as a asynchronous network. So it does not make any sense for asynchronous receive primitives if you don't need to get any responses from the process B. Okay, then is blocking primitive. Blocking primitive means a primitive is blocking if control returns to the invoking process after the processing for the primitive completes. Okay, so if you are sending a messages or receiving a messages, The sending messages have to send to the destination. Till now no other sending will be happen. The same thing for the receiving. So if receiving the message, all the messages have to be received from the sources. Till now no receive messages will be initiated. Okay, so this will be blocking. So each and everywhere the sending processor and the receiving processor, it will be stop or blocking based on this receiving or the sending the messages. That will be, we can call it as blocking primitive. The next one, non-blocking primitive. Non-blocking primitive means if you are sending a message, automatically we can start another work. Okay, we another send and another receive will be taken in the particular processor itself. And if you are going for the receiving side also, if you are going to receive the particular process itself, messages itself, we will be receiving the message. Okay, then we will be starting another receiving also possible and another send also possible, because we are working with the non-blocking primitive. So see this example. Yeah, primitive is a non-blocking if the control returns back to the invoking process immediately after the invocation. Okay, even though the operation has not completed, we are not waiting for the operation to be completed, we will immediately after the invocation. For non-blocking send, control returns to the process even before the data is copied out of the user. For non-blocking receive, the control returns process even before the data may have arrived from the sender. Okay, thank you.